Good afternoon and welcome to today's webinar, Considerations for Flatbed Knitting. My name is Jennifer Lee and I'm the Manager of Marketing and Industry Programs at Cotton Incorporated. We are bringing you today this webinar through Cottonworks, with hundreds of easily searchable resources. We're your go-to textile tool for discovering what's possible with cotton. Throughout today's webinar, you can type questions in the Q&A box, and we will read them out and have Q&A at the end of the webinar. And in a few days' time, a recording of this webinar will be available on cottonworks.com. Now I'm going to turn things over to today's webinar presenter, Isabel Archer.
Hi, and welcome to today's webinar. We will be talking today about considerations for flatbed knit design. My name is Isabel Archer, and I am the Technical Manager of Knits here at Cotton Incorporated. So there are many choices involved with designing for flatbed knits. I have split these into 3 categories, and we'll talk through each category in turn. So design choices are the choices that we need to make before we begin programming. Then setting up to knit will be programming, test swatches and digital fabrics. And then we will talk about what we can produce from the machines, so yardage, shaped goods and integral knitting. So what actually are flat knit machines? These can be differentiated in the industry by the way that the needles are laid out. So flat knit machines have 2 flat knitting beds that are positioned like an upside down V. You have a front bed and a back bed, and all of these are filled with grooves or tricks, which is where the needles sit. This is different to circular machine, whose needles are set up in a circle. So on flat knit machines, the carriage moves back and forth along these needle beds, telling the needles at what height to push up to in order to knit. These needles grab the new yarn that's laid into those hooks and pull back down through the old loop and create a new row of knitting. So we also need to decide what kind of yarn we are going to knit with. There are a whole range of different novelty yarns and different methods of twisting yarn to create different effects within the fabric. There's a few shown on this slide. So the first is a plied yarn. It's always advisable to use at least a 2-ply yarn on a flat knit machine. This reduces the torque or the twist in the fabric. We also have slub yarns or nep yarns, so we have thick and thin areas within the yarn which show up as bubbles or irregularities within the fabric. We have heather yarns, which are where the fibre, different coloured fibres, are mixed together and then the yarn is spun from that. It creates a more integrated colour blend. We have cabled yarns, which is multiple different colours twisted together. We have high twist yarns where the twisting process is exaggerated and it creates quite a dry hand. These are great for pointelle stitches. They hold a really open stitch. We have mercerized and gassed cottons. These give extra shine to the fabric, so we get an almost silk-like look. The opposite of that is the chenille yarn, where you have a central core and cut ends that go around that. These are also normally 100% cotton. And there's boucle yarns as well, which again have a central core and then an overfed yarn around it, which causes a curl within the yarn. There are many, many more different kinds of yarn. Novelty machines vary from country to country, so depending on where you're sourcing your yarn from, you can get different types. Machine gauge will play a huge role in how our final fabric will look, and gauge is measured per number of needles in an inch on the flatbed of the machine. You can see in this first image we have 14 needles per inch, so this is a 14 gauge machine. Flatbed machines tend to range in gauge from 3 gauge, which is a very chunky stitch, to 18 gauge, which is much finer. And you can see the needles on the right hand side, that the 3 gauge needle is much heavier, has a much bigger hook than the finer 18 gauge needle. And this is because we need to get more yarn into a 3 gauge stitch than we do into an 18 gauge stitch. A great thing about flatbed machines is that we can also multi-gauge on them. This means that if we were to knit on every other needle, we will have 7 needles per inch and therefore a 7 gauge machine. Not only can we knit 14 gauge and 7 gauge, but we can knit both within the same garment, so 14 gauge cuffed, 7 gauge body, or vice versa. We can also knit different gauges within one row if we balance out the number of rows for the size of the stitch. We could also, like the example that you see on the screen, knit 14 gauge on one bed and 7 gauge on the other bed. So there's many varieties when it comes to multi-gauging. The stitch that we choose to use on our fabric will not only give a different aesthetic, but will give different performance characteristics as well. There are 3 stitches that we use in knitting. This is a knit stitch, a tuck stitch, and a miss or float stitch. When a knit stitch is performed, the needle is pushed up by the carriage to its fullest height. The old loop or the old stitch slides down past the latch of the needle and a new yarn is laid into the hook. As the needle pulls back down, it pulls this new yarn through the old loop and a new stitch is formed. With a tuck stitch, the carriage only pushes the needle up to its halfway position, and in that halfway position, the old stitch stays within the hook or doesn't pass the latch of the needle, and then a new yarn is laid in. So rather than just having one stitch in that hook, we now have 2 pieces of yarn. This causes that row of knitting to tuck up into the next row. The third stitch that we use is a miss or a float stitch, and this isn't really a stitch at all. In this case, the carriage just passes over that needle, the needle doesn't move anywhere, and the yarn floats to the back of the fabric. Everything else that happens after this stitch is performed is a manipulation of those 3 stitches. We have many controllable elements to each of the stitches. The first one being the yarn that we use. Most machines have between 16 and 32 yarn feeders, so that means we can use between 16 and 32 yarns per fabric. The second thing we control is the amount of yarn. So are we going to have an open gauzy stitch with lots of yarn in it, or are we going to have a tight stitch where little yarn is put into it? The next thing that we've just been through is the stitch, so we can choose what happens with each of those stitches. And then finally, the movement of stitches. So stitches can transfer from the back bed to the front bed or vice versa. They can also move to the adjacent needles, which causes a pointelle hole. We can also move the stitches at the edge of the knitting to change the shape of the swatch. By manipulating many of the factors that we've just talked about, we can come up with a whole range of different stitches. The first stitch on this slide is a jersey or reverse jersey stitch, which is our basic knit. We then have rib stitches, which are columns of jersey and reverse jersey stitches, and we can lay those out in a variety of forms such as 1x1, 2x2, 3x3, and so on. The next swatch shows a tuck stitch, which we've just covered, where rows are tucked up into the row above. And then we have a cable stitch, where the position of certain stitches are swapped over with other stitches to create a twist in the fabric. The next 4 swatches on this page are all jacquards, just different kinds of jacquards. Some of them are single bed and some of them are double bed. But the main similarity between these is that they all have multiple yarns or multiple colours of yarn in them. And in all of them, that yarn travels from one side of the knitting to the other side of the knitting and either floats or knits behind the rest. A few more stitches on this page. The first one is the intarsia stitch, and this differs from a jacquard stitch because although we're using multiple yarn feeders of different colours or different textures, those specific yarn feeders only stick within their specified areas, knitting back and forth. That way we can create a multicoloured or multi-textured fabric that is lighter in weight. The next stitch on this page is a linked links, which is a combination of jersey, reverse jersey stitches laid out in whatever pattern that you're trying to create. Next we have an inlay stitch, which is very good at mimicking a woven, and we can often use thicker yarns on these as we are not knitting that inlay yarn, we're just tucking it into the back fabric. Pointelles, which is the next swatch, can be used in a variety of different ways to create decorative patterns or performance-based fabrics such as meshes. We also have ottomans, which is a double knit fabric where multiple rows are knitted on one bed, causing a ripple or a welt in the fabric. We then have a float stitch, which is similar to the inlay in that we are laying a yarn in that the ground yarns transfer back and forth over. Plating is a great technique on the flatbed machines, but circular machines can also do this. This is where we can add a second yarn into the same stitch. So we have a leading yarn which will always fall to the jersey side and a following yarn that will fall to the reverse jersey side. This can be used a lot for performance fabrics, for example, when we want to add a stretch yarn into a hem or a cuff to give better stretch or recovery. But we can also use it in a decorative way, as we have done in this image here, so that you can see both colours of yarns within the same swatch. The final fabric on this slide is a plush stitch, and this is a jacquard plush. And this is where we create a loop on one face of the fabric and then knit that heavier yarn into the ground. So these are just some of the decisions that you need to make before moving on to program your flatbed machine. The software that you can see on your screens right now is proprietary to the knit machine manufacturer, but all of them seem to work in a fairly similar way. And that is the first thing that we need to do is to create the actual image on the screen. And we do this by using basic drawing tools that you see in a lot of design packages. So we have all these various draw, fill, copy tools at the top here. We can then also select the colors that go onto all of these squares. And that isn't necessarily representative of the yarn itself, but is just representative of the feeder. We can then go into programming our stitches, so we can also put those into the same squares. So we have our knits, our tucks, our misses, our transfers, and variations of those within here. These icons down here represent modules that are pre-built into the machines. So these make it easier to program certain elements. So if we have a multi-step command like a pointel, we can just use one of these modules and add it to that square, and it will carry out the multi-step process without us having to program it in. Over here, we also have control columns. These ones control the takedown of the knitting coming off the machine. We can control the speed of the carriage. We can also control how much yarn goes into the stitch, so if we want a tight or a loose stitch. There are many other features that we can use on this program because this goes all the way to programming entire garments, but there's a few just to start off with. Once we have programmed our basic image, we then need to process this into knit language so the machine knows exactly what it's doing, which carriage movements it is making and which stitches it is using at that time. So this process view becomes much more elongated. You can see there are blank spaces within this, and these are unused rows. So at this point, nothing is knitting. We want to keep that to the smallest amount possible because when we're doing that, the machine is running without knitting, and this makes the programs knit more slowly. Once we have completed the processing, we can see a virtual rendering of our fabric. And again, this isn't in actual colours, this is in colours selected to represent the knit feeders. This is another example of software used for programming flatbed knit machines. This is by a different machine manufacturer, but again works in a similar way. Here though, we are using these colours at the bottom to represent the stitches. So we can see that this red stitch here is a jersey stitch. So all of the red stitches on this screen are jersey stitches. We can see that this turquoise colour here represents a pointel stitch. So all of these turquoise stitches are pointel stitches. The control columns, we have 20 on the right and 20 on the left that you can't see on this screen. But this is where we control which yarn feeders are used, how fast the machine is running, what direction the carriage is running in. We control all of the elements of the program here. Again, we have the same processing tools or similar processing tools because this program also needs to be turned into knit language in order to transfer it to our machines. Once we have finished our programming on the software, we can then transfer that program to the machine either by USB or by Ethernet. So now that we have our program complete, let's look at what we can achieve on these machines. Body mapping is a great thing that we can do. It allows us to use different yarns and different stitches in various different places on the fabric or on the garment. This can be for either aesthetic reasons or for performance reasons. So for example, if we needed an area of greater stretch and recovery, we could add a rib, or if we wanted an area of breathability, we could add a pointelle mesh stitch. This saves us a lot of time in garment processing or garment manufacturing because we don't need to cut and sew all of those separate performance fabrics and stitch them all together again. It also produces a higher quality garment as there are fewer seams that can rub. It has a sustainability story as well because we don't incur so much wasted fabric. Because we have the ability to transfer stitches, we can create shaped or full-fashioned pieces. And this is where we knit to our exact size or specified pattern piece. We do this by transferring the edge needles to adjacent needles. And so we transfer those out if we want to make our fabric wider, and we transfer them in if we want to have a narrower fabric. When we are narrowing our fabrics, we quite often get full-fashioned marks. This is a slight bump in the fabric where two stitches end up on one needle. It's generally seen as a sign of quality in a garment. The beauty of being able to shape or full-fashion garments is that we are not wasting any yarn when we do this. There is no excess cut and sew fabric that will be left over, so it's a great sustainability story. When we have completed our knitting, we can use various different methods of seaming to construct our garments. The preferred method that is used for knitwear is linking, and a linking machine is a cylindrical machine with pins all the way around the edge. We can put our knitwear straight onto these pins, which helps us when we are trying to line up a pattern or insert an armhole. The machine itself then creates a chain stitch along each of these pins. These machines are great if we are also trying to put something on stitch for stitch, like a neck trim, as it gives us a really neat finish. This isn't the quickest method of garment construction for knitwear. Cup seaming and overlocking are both much quicker, but they don't lead to such a quality finish. Flat knit machines are also capable of producing garments that don't require any seaming. So these are referred to as integral knits, and they are created on the machine by knitting in one direction on one bed and using the same yarn in the opposite direction on the other bed. This creates a squashed tube of fabric, which we can still incorporate all of our stitch changes, all of our yarn changes, and all of our shaping too. There are more complex machines that have 4 knitting beds where we can store those extra needles or transfer those extra needles so that we can add more details into these integral knits. Again, this is a great sustainability story because not only are we cutting down on the yarn usage, we are also cutting down on the after processes that need to be carried out. 3D knitting differs slightly from integral knitting because we are adding that extra dimension. A good example of this is on the sleeves of this sweater, where you can see certain parts have more rows than others. We achieve this by partial knitting or short rowing, sometimes also called goring or flechage. And this is where the carriage moves back and forth along certain areas rather than just knitting in a straight tube. This is great for garments as it allows a better fit, but really comes into its own when we are knitting accessories or shoes, automotive products, and interior fabrics such as covering furniture. Digital fabrics are being used more and more, and we can look at these straight from the knit programs that we use. So after we've processed our swatch, we can see that digital rendering. Certain programs, like the one that you can see here on the right, even allow us to scan our own yarns in so that they can be used as an exact replica on the swatches. The great thing about digital fabrics is that they cut down on a lot of the knitting time. So we no longer need to knit multiple colorways. We can see those in digital format. The designers can decide from there. So again, we're wasting a lot less time and a lot less materials. At Cotton Incorporated, we also use an external source to digitally map all of our fabrics that are in our Fabricast line. These are available for free download on our Cottonworks website, and they can be used in both Clo and Browseware. These digital fabrics can then be used to create virtual garments, which cut down on sampling time, it cuts down on cost, and it cuts down on unnecessary wastage of materials. At Cotton Incorporated, we also use Clo and Browseware to create our virtual garments. The process that we go through to do this is that I will program a swatch, which we can then approve from a virtual rendering. I then knit a physical swatch, which goes off to be digitized. Once we have these Clo and Browseware files, our 3D designer can create our virtual garments. A great thing about creating on Clo and Browseware is that when we make that virtual garment, we are applying the patterns to virtual pattern pieces. Therefore, I can take the measurements straight from those pattern pieces and apply them straight to my knitwear program. By doing this, we can create a first sample that is near perfect, as opposed to the long process of fittings and remakes that we have gone through in the past. Thanks so much for listening. I hope you've enjoyed this look into considerations for flatbed knit designs. I think we've got some time for some Q&A, and I'm going to hand it over to Jennifer now, who's going to lead this.
Thank you so much, Izzy, and thank you everyone for your joining us for the webinar. So I'm going to let everybody put their questions in the Q&A box, and I will start asking Izzy some of them. So Izzy, the first question is, how do you go about learning to program for these machines?
Okay, well, I think everybody's path is a little bit different. For me, I went to university to study fashion and knitwear design, and I then sort of worked in the industry for a long time as a designer before realizing that what I really wanted to do was program these machines. So fortunately, there are some companies out there who offer these training courses, and I was able to take lots of those until I could program quite well, and I had a very supportive company that is very good at putting into an individual's education as well. So that was a great help.
Wonderful. What are a common range of gauges for these machines?
So range of gauge for flatbed machines tends to be, the chunkiest is, I think they actually do a 1.5 gauge machine now, so really quite heavy. I've just been seeing some samples knitted on those, but more common is a 3 gauge. And then all the way down to the finest gauge, which is 18 gauge. This does give pretty fine fabrics, but when you compare it to circular knits, they can go so much finer.
And how long does it take to produce fabrics or garments on these machines?
That's kind of like a how long is a piece of string question. It depends very much on so many different factors. Like it depends on your gauge. If you're knitting a heavier gauge, obviously it'll be quicker knitting because you've got fewer stitches. It depends on how complex your stitches are or how difficult your yarn is to use. Do you have something that runs easily at a fast speed, or do you have to be a bit slower with the movement of the carriage? There's certain techniques that you use as well, like shaping and binding off, that take a little bit longer. And then I guess it's down to the skill of the programmer in a sense, because you want to make your program as efficient as possible. So kind of like where we saw on the slide with the shoe program, that's very complex. So you have a lot of emptier rows where not so much knitting is taking place. And we want to minimize that. So we try to make our programs as efficient as possible.
So kind of related to speed, how is the cost per garment analyzed for garments knit on flatbed machines?
So a lot of the cost factor of flat knit garments comes down to machine time. So I think it's, I can't even remember the percentages, but it's down to your yarn cost and the time on the machine. So by cutting out, say, 5 minutes on your runtime of a garment can greatly decrease the cost of your actual finished product.
Great. And on multi-gauge knitting, what are the rules on what gauges can be transferred between?
So certain companies call their machines by their kind of multi-gauge number. So they might call it a 7.2 machine, whereas it actually has 14 needles per inch. So it's a 14 gauge machine. But when you use every other needle, it's a 7 gauge. So certain companies call that a 7.2. But virtually all machines can do multi-gauging, but it's just basically half the number of needles of your gauge. You can multi-gauge between the two of those.
Great. Can all these stitches that you talked about, pointelles, jacquard, ponte, can they be done on both flatbed machines and circular machines?
No, not in all cases. There's different flatbed machines and there's also different circular machines. So there's not a great deal of circular jacquard machines out there, for example. We do happen to have one at Cotton Incorporated, but I know they're not commonplace in the industry. Flatbed machines have a much, much greater capability for the number of stitches that we can do, for the amount of manipulation that we can do per stitch. And part of that comes from the fact that we are running so much slower with, a lot fewer yarns than on a circular knit machine. A circular knit machine can do 60 revolutions, 60 rows in one revolution. So with that, you have very little time to manipulate anything, whereas flatbeds have much more control and a much slower speed and run with much fewer yarns, but can have all of those capabilities.
And so related to that question, what is the difference between 3D flatbed knitting and seamless circular knitting?
Okay, so seamless circular knitting tends to be a machine that is a body width. And so you are creating actual tubes of knitting rather than flat tubes of knitting. And then you play around with various different yarn types that have different properties, and you play around with different stitch structures to bring that tube in and out and add your patterning within it. With a flatbed machine, you have even greater control than on a circular knit seamless garment. Circular knit can knit one tube at a time, whereas a flatbed can knit multiple tubes at different times. You also have a greater play of stitches. And then it gets very confusing in the industry because circular garment machines are often referred to as seamless, when in fact they're coming off the machine still as a tube, and you still have to finish all of your edges in, one of the construction ways that I talked about earlier. Whereas flatbed machines can do truly seamless garments.
Great.
It's a confusing terminology in the industry.
It is. So speaking of those types of seaming methods, someone asked if you could explain the difference again between cup seaming and linking.
So linking is definitely the preferred method because you can put your knitting onto those pins stitch for stitch. You knit your trims with waste yarn on, and then that very last row of knitting before it turns into the waste yarn, you put that onto the pins stitch for stitch. So you catch every single loop. If you miss a loop, that stitch is going to run through your fabric. So it is very skilled people that need to be doing this. It's also very labor intensive and very hard on the eyes. So it's generally used in much higher quality garments. It's harder to do as you get to much finer gauges. So when we do get to those finer gauges, we need other alternatives, and cup seaming is one of those. And that is where we can run both of the pieces of fabric together at the same time through a machine. It will help it to unfold the edges and works more like a sewing machine, but it won't bind off your edges.
Great. So these machines, after you've designed the stitch structure in the computer, how hands-off or hands-on is running the machines? Do you have to transfer stitches or move the carriage manually or do the tensioning? How much of it does the machine actually do?
In an ideal world, what you do is we all know this isn't true if you've ever done any knitting, but in an ideal world, you take your USB with your file on it, you load it into your machine, you've set up all of your yarns, which of course you have to do by hand, and then you switch it on and it runs perfectly and it comes out of the machine at the other end. You do not sort of have to do any hand manipulation yourself. The machine does all of this for you. But in reality, it's a little bit more hands-on. There's normally a few prototypes where you're sort of running the machine very slowly to make sure all the stitches are doing exactly what they're supposed to be doing, that all your needles are working correctly. And then going back to the program and tweaking bits because maybe the shaping is too tight, or this stitch created a hole because there was not enough, play in the yarn. And so although you don't do any of the hand manipulation like you do on a domestic machine, there is a certain amount of playing about that you have to do to get that swatch final. But once the program is done and signed off on, it's good to run and you can leave the machines running all night.
So we've had a couple questions about Chloe and Browseware, and Izzy, just let me know how comfortable you feel with answering them, or if we should refer people to some of our digital content that we've produced. How are Chloe and Browseware able to render the knit stitches like pointelles or tuck stitches?
And that is something that I would actually pass off to our 3D programmer. I don't program the garments myself. There's certain knit system, like some of the knit software obviously renders this very well, and some of those programs then take it into Chloe and Browseware. But there's a difference between the softwares that can and can't do these.
And how common would you say it is in the industry for companies to be using these 3D digital samples before actually knitting the garment?
I see it more and more. And, I've been at a conference recently where, that is what is being pushed as the future of knitting. The Chloe is, Chloe and Browseware are both sort of getting out of that video game realm and really entering fashion and making improvements very quickly. It's becoming a lot more user-friendly for designers, and they are kind of closing that gap between being a designer and being a programmer and actually getting what you want out of the machines. So I think they're a really great tool that are going to be used more and more. I think it's taught at most universities who do fashion and textiles these days.
So related to that, do you see the industry more widely adopting this whole garment integral knit setup?
I do not see it as the whole industry. It definitely has its place and has so many great opportunities for those high-end garments. Flatbed machines are never going to produce fabric as quickly as circular machines can do. So that, there's there's little reason to make a basic t-shirt that you want to be as fine a gauge as possible. But when you add in the elements of different stitch capabilities and different yarn capabilities within the area of the garment, so you can body map, you can shape, it becomes a lot more feasible, a lot more worthwhile, and a lot easier to demand that higher price point for it.
When creating these 3D garments, how is the correct drape and proportions achieved from the knitted yarn?
So that comes into play when we are doing the digitization, I hate saying that word, of the swatches themselves. So it's not just a case of scanning the fabric and then using that. It's a case of mapping all of its physical properties, like its drape and its stretch and its sheerness and its sheen. And there's various different maps that are taken from the fabric before being used as a Clover or Browseware file, so that these can be manipulated within the program and the fabric actually behaves like your fabric would behave.
Thank you. So a couple questions about limitations of flatbed knitting. So what are the restrictions regarding the amount of colors that can be used in a garment?
So flatbed machines generally have between 16 and 32 yarn carriers. We normally reserve a couple of those for casting on and for draw thread yarn. But then the rest of the feeders you can use to your heart's content for as many different colours or textures as you like.
And
so,
how do elastic yarns work on these machines?
So we use elastic yarns for casting on. We generally, at Cotton Incorporated, obviously we want things to be made in as much cotton as possible, and these machines are great for knitting cotton with. There is also an awful lot of sort of elastic yarn, synthetic yarns within performance wear, athleisure wear. And so we want to, at Cotton Incorporated, we want to show that these are possible on flatbed machines, but with a natural fibre. So I think people still generally prefer natural fibres against their skin. And cotton also has great inherent properties, such as, antimicrobial, and so it's nice to be able to show that we can replace that stretch, those synthetics, as much as possible. But of course, we're still going to need to use them on occasion.
Are there any other new innovations in flatbed knitting besides 3D knitting that you have seen or heard about?
It seems like at the moment there is something new every other month. Certain manufacturers have just updated their programming and their software to make it easier for designers who don't program to be able to use. And that's where you're more kind of drawing your garment as opposed to knowing exactly how the stitches need to transfer in order to get you to the next row, or the kind of minutiae of programming. And so I think that's a great thing that they are working on. And then also, as we said before, the virtual garments is a big space that they seem to be working towards. There's constantly little machine tweaks here and there as well, like machines that can insert hard goods into the fabric with a little electronic arm, or ways of getting different kinds of fibers into the machines, so to make knitting a wider range of materials more possible. So there's always something that they're coming out with. Yeah, it's a tough industry to keep up to date with sometimes.
Great. Thank you so much, Isabel. And thank you everyone for joining us today. That is all the time we have for questions. But within a few days, the recording of this webinar will be live on our Cottonworks website. So if you need to go back and watch it again or want to share it with a colleague, you can find it there. Thank you so much, and we hope you enjoy the rest of the day.
Thank you. Bye-bye.